All right, let's do it, everybody. Here we go. Three, two, one. Aloha and welcome to the Solar Coaster Live Show here with I'm Josh Porter in Makawao, Maui, and my co-host Jason. Where are you calling in from, Jay?
Good morning. I'm back in Osaka. We did our California trip and it was a hell of a lot of fun, but had to come home.
Yeah, it's great to be back on air and to be doing some follow-up shows. And we've got a great guest from Tigo, Mrs. Jing Qian, and she's a really knowledgeable person in this space. Miss Jing, would you like to introduce yourself?
Yes, thanks, Josh and Jason. I'm Jing Tian. I'm Chief Growth Officer with Tigo Energy.
I'll tell you what, you're very welcome to be here. So nice to see you, Jing. I'll tell you what, JD reached out to us before RE Plus, which feels like another world at this point because RE Plus was so, momentous with 27,000 people coming together and it felt like kind of the get back together event. But there's so many great things happening in this space. And JD reached out, and I know him from earlier days. And he said, "Hey, we really got to get you on air with us because Tigo's doing some really amazing things in the solar plus battery world." So, and of course, we have an understanding of Tigo because way back when Tigo was one of the only companies that I was aware of in the kind of inverter agnostic, if I can say that, DC optimizer space. So, and for some people, they may be thinking, what does that mean? Well, it's like back then, what I remember, and correct me if I'm wrong here, Jeng, but what I remember is that those optimizers, you could spec those in a system. If you were creating a system, a commercial system, or maybe an off-grid system with old radians or something, you wanted to have optimization for different reasons on roof. When I mean optimization, I mean panel level optimization. Then you could spec Tigo, and it was an amazing solution to have that kind of flexibility at that stage of the game. So yeah, really, that's what strikes me. Is that kind of where Tigo came from?
Yeah, so Tigo, it's been in the module level power electronics business since 2017.
Right.
Yes, so we have a family of a product that we call TS4. So you mentioned the optimizer. We also have a module level monitoring only, and also have a rapid shutdown device. But it's all in this family, and the flexibility is the key. So we maintain our flexibility and the open architect, and that is to work with all inverters. It's inverter agnostic.
Isn't that an interesting value proposition, Jay? And I remember that it was the fire protection, it was the rapid shutdown, and then I guess the DC optimization, right, as well.
Yes.
And so you had like a color chart or something, and it was like you could do this color, this color, all three of them. And
that's correct.
Kind of about Tigo. So it's super cool. How about you, Jay? What do you think about today's show? What say you, sir?
Oh, I immediately recognized the name. Back in the day, it was the only one. If I remember right, you received a government award for the development of these technologies. It was specific to safety features that basically no one else was providing, and so it was obviously on our radar immediately. So very happy to have this conversation.
Yeah, no, thanks. Yep. Yeah.
So you'll notice, Jing, that Jason has his green screen as his background. And we just decided, hey, that's Tigo Green. So we might as well roll with it. So yeah, that's Jason's tribute to Tigo, to the guest in today's show. So, all right, well, let's just dig right in here, Jing. I want to give people that are listening an opportunity to understand a little bit about the background of Tigo before we jump into the solar plus battery tech and all the kind of cool value propositions that, of course, come along with that. So can you give our listeners a sense of kind of who Tigo is, what the background is? You just mentioned, of course, the module level offering. How did it all start out?
Yeah, we started out in 2017 as a Silicon Valley based startup company. So we've been in the business since then. Mostly our original innovation is really based on the module level power electronics. So we have gone through multiple generation products. So today this is our main product. We're still providing Tigo TS4, and we have the latest product with a much higher power, 700-watt power, and 25 amp maximum ISC. So we evolving over those years to meet with the modules, PV module with the increased power, increased current. And then we also try to work with all different inverters. We have more than 900 inverters tested, compatible worldwide. And the other very important asset is given we know about the DC optimizer. So we've developed a very comprehensive, what we call EI monitoring platform. It's our software that's giving you the module level visibility. So that's monitoring, but in addition, it's actually provide a lot of a fleet level view that which is expanding to the operation and the maintenance for customer to use our product. And so that is the main products we've got coming all those years. So last year we introduced the inverter plus storage solutions.
I see. I see. So what occurs to me is I'm trying to get a read on kind of where Tigo fits in the market, up until now, in terms of utility, commercial, residential. And I can imagine you just mentioned fleet, which is interesting. So, if you're an installer and maybe you have 500 installs across your community, and then you want to know how those things are doing, you're saying that your software can kind of reach out and see that all simultaneously. Is that right?
Yes, yes. So we have an installer's views. They have then also have a different level of details to monitor, current voltage, is the signal strength. Interesting enough, we can actually help diagnose lots of problems remotely. We can almost solve greater than 97% of problems remotely. So significant saving the operation and the maintenance costs, reduce the truck rolls.
Truck roll. That's the phrase, right?
That's interesting. What kind of problems specifically are you?
We will see people with the monitoring issues, with the, sometimes it's shorting, modules not working. So what's really easy is to identify, pinpoint where the problem is. Right, so you've got a particular location. We have several case studies. Some of it just, you have an excess amount of bird droops, and the causes to module not performing. And the other thing is, you mentioned earlier about the scales. Our technology is very scalable. So we've deployed systems from a few kilowatt system, residential systems, to as big as 20 megawatts of large ground mount systems. Yeah.
Right. And I can imagine that would be on the commercial. So that's kind of the full gambit, right? A couple kilowatts to 20 megawatts is utility scale. So in the middle there on the commercial side, that would probably be very valuable, because some of these systems, they can be pretty large on roof, like a Maui brew, of course, Jay, is what I'm thinking about, and these kinds of systems, you may have thousands of modules. And if you don't have some granularity and some visibility as to what's happening, then birds might be dropping, or you might have in the case of Cuddy Hunk Island, they might, they may, Jay knows what I'm talking about.
Yep. Drop clams.
Drop clams to break them, the birds, maybe on the glass, right? So you want to know if a bird's dropping clams on your photovoltaics, so you can fix it. So and it's all about that O&M cost, of course. Now that the solar industry is maturing, that O&M is becoming more and more relevant for everyone, whether you're an individual with a 2 kilowatt array or whether you're the big utility scale guys. And so having that visibility, the fleet visibility, all of that's going to become more and more important, because as you mentioned the term truck roll, and that particular phrase is scary for O&M guys, because a truck roll is expensive. You generally got 2 guys. You generally got X amount of time to a place. Then you got to go out and diagnose. And then you got to, maybe you have the stuff you need to fix it, or maybe you don't. And then you got to go, so the expenses can really stack up a lot with the truck roll. So anytime you can kind of nip that in the bud early, now you're creating better long-term economics for the system, which is what it's all designed to do in the first place, right? So very cool. Very cool. So, all right. So that's kind of some of the background here. Now, we, of course, love solar plus battery systems, and we love geeking out on this stuff. Jay and I are talking about them as they emerge. And of course, the market now is becoming kind of like more populated. For years, we didn't have a lot of options in that space. On-grid solar batteries, there were only a couple of options. Now we're seeing, a lot of great kind of contributors come in and say, hey, we've got this technology. In the case of Tigo, we've got this expertise in this kind of area of the industry. And now we're moving into the solar plus battery space. And that's really the kind of meat on the bone that we're going to talk about today. So why don't you introduce some of this technology? Give us a sense of what's going on with the evolution of Tigo into the solar plus battery space.
Yeah, so we see that the market needs as well. Market is looking for alternatives, right? So
Mhm.
in additional players into market. So what we do is we build on our knowledge because we monitoring over, actually, I was gonna say, um, 50 over 50,000 units of systems. Those only Tiger monitored system, right? So it's a lot of non-monitored system. So we understand the system behavior, how it performs. So leveraging those knowledges, so we work with, to build a Tiger's solar plus storage. Primary initially we enter into the commercial residential market as we see there's a great need in this segment. So our products are DC coupled. So we have three different inverter sizes: 3.8, 7.6, and 11.4 kilowatt. And then we have a DC coupled batteries is up to 40 kilowatt hours. Depends on how big you want a battery. So start with a 10, go up to 40 kilowatt hours. So it's got be able to do critical load backup or to whole home backup. And the system itself can configure. It's a primary build for DC couple. It's a hybrid inverter, but we can also configure into AC couple. So I'm aware that in Hawaii, in addition to building lots of new solar plus storage systems, you also have existing PV systems. So you're looking for adding batteries. Our system
Yes.
can work as an AC coupled as well.
Yeah.
Yeah, Jay. So, there's a certain level of flexibility that's unique there, right? So,
Yeah.
what I heard was 3, 8, 7, 6, 11, 4 on the
Mm-hmm.
inverter sizing, which pretty much carries the gambit of what you would want on a residential system, and then up to 40 kilowatt hours per inverter. Is that right?
Correct.
Right,
Yeah.
40 kilowatt hours of energy. And then, of course, we didn't touch on it yet, but you spec lithium iron phosphate. Now, is it lithium iron phosphate exclusively? That's what you're using?
Correct. Yeah.
Right.
It's much safer battery. So yes,
Right.
it's
So
a safety. Yeah.
you don't need any active cool. And from safety guys, you guys are fire suppression.
Yeah, that's classic Tiger.
You're like, we know about
Yes.
this stuff. So you chose LifePo, which is interesting in and of itself, right? And we're seeing a
Yeah.
lot of movement into LifePo now.
Yeah.
So let me just think a little bit about the sizing here. So I also read that you could stack your DC to your inverter at a 200% ratio. Is that accurate?
That's correct. Our inverter to DC AC ratio is 2 to 1, so it's given lots of oversizing
Right.
on the PV size, that which allow you to charging to the battery during the peak production of the PV system.
So this is kind of interesting. And for someone at home that's thinking about getting a solar system or adding some batteries, they may not be thinking about this, but because it's a DC coupled system, that extra DC that can go directly into your batteries. That's what you just said.
Mhm.
So it's not going through the inverter to the battery. You're not inverting or rectifying in order to store. You're at a very high level of efficiency. You have a PV panel, you have an optimizer, you have your TS4, I assume, in there, and then you optimize at pretty darn high efficiencies. DC coupled systems are efficient by nature, and then you're storing directly in the DC. So, but simultaneous to that, if you have, let's say you have a 7.6 inverter right in the middle of the road, and you have 15.2 DC on roof, 200%, then you could throw 7.6 at that inverter all day long, and the rest could be storing in the battery essentially, right? So you could use.
Correct.
So you're not necessarily clipping with that type of an architecture. Clipping meaning curtailing your energy production and storage and consumption. So pretty interesting stuff. Jay, what do you think here?
Somewhere in there, there's the opportunity for EV charging as well, if I read that right.
Yes, that's in our product roadmap. That will be
Yes.
coming next 2023. Yeah.
Because that's all I can say. Like if you have that much solar and that much, you can store that much energy, and then you can just where are you going to put it? That's always the conversation we have right now.
Right.
You're generating all this energy. What are you going to do with it? Mr. Porter likes to say the abundance of energy. Well, we have all these electrons. 40 kilowatt hour is pretty respectable. I do want to say that right off the bat. But still, like these EV batteries, people don't
bigger.
understand are an order of magnitude larger than even the largest home battery. And so we really want to leverage that as a storage medium as much as possible. So having that EV charger on the roadmap is a big deal.
Yeah.
Really is.
Especially then you can use a time of use, because we have a mode for time of use. backup mode. So with all this, you have additional large load that give you lots of flexibility in terms of when do you want to charge, when do you want to discharge, when do you want to store the energy. Yeah.
That was going to be my next question. So this TOU thing, we've talked about it a lot on air, but it's still very new in Hawaii. So we're not quite sure how it's all going to shake out. We have a lot of people on the classic NEM systems that are going to be basically aged out. They don't know how they're going to be managing their energy. It's always just been the grid as one big battery. I think this home battery system is going to be a seriously attractive thing for people going forward because of the way that the politics are shaking out.
So there's a lot to kind of talk about here, and I definitely am excited to talk about how this system applies specifically to the new TOU rates here, and I can imagine some discussions on that. But before we get there, I want to think a little bit about just to kind of wrap up the how the system might be installed. So on a DC level, you've got 200% DC AC ratio. You got a lot of potential PV on roof to a given inverter, whatever you choose. You've got up to 40 kilowatt hours of lithium iron phosphate, which is very safe, probably doesn't require active cooling, for example. Is that stacked on a wall? Is that outdoor? That's outdoor for HECO ratings, right?
Yeah, it's rated for outdoor, so it's not a wall mount because our LFP battery is very heavy. But you can lean against the wall. So there's a bracket to hold the battery in place.
I gotcha. So it's kind of maybe got a stand and on a bracket, and it kind of sits next to the wall, and it can be out.
Does it need a pad?
You can build a pad, yes.
Yeah. Okay.
And so when you have, I want to get a sense. So if someone had, if someone was putting in a new system, they would deploy it in that way. If they were, let's say a NEM system like we were just talking about, and they go, oh, I need batteries, and I like Tigo because of this focus that and this background they have on safety and fire prevention and things like that. So maybe they get excited about it and they wanted to do it. What does it look like in that scenario? What does an AC coupled system deployment look like?
It looks the same. So you have your PV system come in with the existing inverter, then you go to the main panel, then you have the inverters and the batteries together from Tigo, that communicates back to the inverter as a two existing inverter. Then the communication between Tigo's storage inverter and the existing inverter is followed by the Route 21 protocol.
Yeah. Right. And the thing that occurs to me is that with your TS4, the optimizers, let's call them that, or panel level optimization, you have this kind of history of working with, you set up to how many inverters? 800 inverters?
Over 900.
900 inverters. So you're kind of acquainted with playing with, let's say, companies in another sandbox, right? You're kind of acquainted with that process, which of course, from an AC coupling perspective, when it could be any of maybe half dozen kind of primary dominant, inverters on grid inverters over the years, you kind of know how to talk to those guys, is where I'm going with this.
Yes, you got it right on.
Right. Yeah. Right. Yeah. Very good. Okay, cool. So that's kind of, you have this, new DC coupled original system design, and then you have the opportunity to come in and retrofit and add batteries. That's very good. And then, by the way, when you were talking a little bit about EV charging here, and Jay probably knows where I'm going to go with this, but it would be great if that EV charger came right to market with bidirectionality. Just a thought.
I got it. I got your
input. Take that for what it's worth.
Okay.
The idea of, because then you're in this very exciting.
I know a number of people who that is literally their deal breaker. They're waiting for that one feature and then they'll buy it.
Yeah, I think it takes two facts. You also have to EV companies allow people to do bidirectional charges. I think it's going to happen. I got a feeling industry is going to moving towards that direction. I think 2023 is the year. Yeah.
No kidding. 2023. Okay.
I'm hopeful. I'm an optimistic person. Yeah.
Yes.
I think we got to have a bidirectional charger. That's just, by nature of it. You got a giant battery in the car. Why not use it? So
It's so it's so exciting.
Exactly that.
Now you've got a little DC microgrid essentially, right? You know,
yeah.
you got your battery, you got your DC optimizer, you got your car, and if they're
Yeah.
just it's just flowing between them, what an elegant design that is. Okay, great. So we got this new system with these value propositions we just described. Let's talk a little bit about what's going on in Hawaii and how this can be an opportunity for people, right? So,
Mhm.
you know, Hawaii is an environment where, and we've said this 1,000 times, but just basic recap, we've got a lot of early adopters in PV over the last decade. And then we moved very quickly to post NEM, meaning we needed to move into new tariffs. It wasn't just the one-to-one exchange of, you know, big theoretical battery, which is what NEM, net energy metering, basically is for people. And we kind of graduated very early in around 15, was it, Jay? Or was that the time?
Yeah.
Was it that early?
Yep. 2015. Yeah, it really was.
Oh, it's hard to even map anymore. So we moved very quickly into post-NEM with new tariffs and then self-supply and on-grid batteries. But for the most part, up until recently, you know, it was kind of, we didn't have a lot of on-grid batteries, but I'd say the last few years, the attachment rate has skyrocketed. And now we're at like something like 70, 80+% of the systems going in have some form of battery. And now we're moving to a place just over the course of the last week or so, post RE Plus, where we saw the time of use rates being we had performance-based regulation on the utility side, which means the utility has to do things good for renewables to get paid. That kind of happened earlier in the year. And then we moved into time of use being, it looks like, approved from the PUC, if I'm not mistaken, last week or so. So what that means is you're going to have different pricing for your energy on a daily basis based on, you know, you got this huge abundant supply of solar in the middle of the day, and they want to charge kind of less for energy then and more in the morning and the evening when it's dark, and they have to kind of provide it. So time of use is something like that. I think we're going to have something like 3 or 4 different rates based on each of the schedules, you know. But what do you think about this system and how it can help people in that? And plus we have battery bonus too coming in, so that's interesting too.
Yeah, so first of all, the time of use, we can set in our app. You have a multiple windows you can set up based on the different days, different times. So if you base on the utility rates, it's at a different rate. So the idea is you want to use as little energy from the grid as possible when it's a peak hour. So time of use in the battery scenarios in the app, what you really think about it is shifting, because by shifting is meaning when the grid is cheaper, you use the grid, try to use the PV, charge the battery. If you don't use the grid, it'd be ideal. Charge the battery, then save this battery to the time it's a peak hour where you use most of the energy at your home. For example, when you make a dinner. So in California, for example, our time of use, the peak rate is between 4 to 9 p.m. So I want to use a 4 to 9 p.m. use my battery, but at noon I want a battery to be charged. Right. So that is allow me to save energy. So I can use a minimum amount of grid energy. Yeah.
Yep. Right. So that's, I guess there's opportunities there for you to program it to optimize for a given tariff structure, like we have here in Hawaii, this new TOU. So you guys will go, okay, well, it costs X in the morning and Y in the middle of the day and Z in the evening. And then maybe there's an off peak car charging rate or something as well. And then, you know, we're going to try to use our solar energy during the day. And then we're going to try to shift it over a little bit to the evening, depending on how we need to use it. That what is that? Bill of the duck, I suppose, right? The duck curve.
Right. Exactly.
So very cool. Okay. Jay's got his finger up.
Yeah.
So fired away.
So, something that you just said, can you charge the battery from grid power? For example, you
Yes.
don't have, yes, that was a yes.
Yes. So we have an option. So customer can choose, say, if you want to charge the battery from the grid. So there's an option there. Yeah.
That's a really interesting, you talk about energy shifting. I mean, you don't even need to have solar at that point. You just have the inverter in the battery and you would be able to buy cheap and then use it later.
Yes. Yeah. You got it.
It's very much a game.
Yeah.
Yeah. And I mean, geez, that's a certain kind of use case too, especially with battery bonus, right?
Yeah. Yeah.
So, yeah. So meaning that you could potentially actually do that and just buy it if it were cheap.
Well, what I'm thinking about, I mean, we have energy issues in the islands all the time. You know, power goes out at my house, a couple times a month, right? And it's just because it's unstable, the energy system. So having safety, having the battery there is
Mhm.
a big bonus. And then if you can also offset the cost of buying that battery by simply avoiding time of use high rate,
Mhm.
it starts to sound a little more attractive.
Okay. Okay. All right. Well, it's a good segue, right, Jay, to over to the notion of power outages. So,
Sure.
of course, solar, it has a green concept to it. Solar has um, a financial consequence to it. You're saving money, over
Yep.
the grid. And then there's other cool things that you can do with solar. But I mean, one of the main things is the concept now with energy security. So tell us a little bit about how this system in particular works in an outage. What are some of the power capabilities? Are you doing load control? Are you doing you meeting certain loads? How are you shifting things around?
Yeah, so we can do our battery depends on how you configure it, right? So if you're doing 20 kilowatt hours, high two battery in parallel, we can provide a 10 kilowatt of the backup power. Now, obviously, goes with 11.4 kilowatt battery. If it's a 7.6, then you minimize, control minimum is by 7.6 kilowatt. So that is a sufficient amount of power to power up some of the appliances in the house.
So what I
Uh,
heard was that the 11.4, if you have two, how is it configured? Is you
if
have
you have a 11.4, you have a two battery comes in, which is 20 kilowatt hour. Each battery give you 5 kilowatt backup power. So two of them adding together, it's 10 kilowatt. Yeah.
so it's 10 kilowatt in off-grid mode effectively.
Correct. For the backup mode. Yeah.
I see. I see.
Yeah.
Well, that's pretty robust. 10 kilowatts. I know just by looking at my power in the house. Jay, you may jump in here because my throat's kind of a little foggy right now. But that 10 kilowatts, it rarely exceeds that. It's very unusual time for me to do that. My home is generally, even at peaks, maybe around 5 or 6 kilowatts, 7 kilowatts, 8 kilowatts. Of course, if I decide to go and turn a jacuzzi on, a hot tub, or a sauna or something like that, now we're in a
The
different.
oven, the dryer. I mean, all these
Right.
appliances that we're used to using that generally take a lot of energy, and you could certainly avoid those. But yeah, it's really hard to get to 10 kilowatt.
Yeah.
You have to want to use a lot of power.
Yeah. Well, hopefully you don't use a lot of power. As in the backup mode, you want the battery to last long. So if you use a lot of power, the battery only get a limited amount of energy, right? So the
Right.
more power use, the shorter the battery lasts.
Yeah.
Yeah.
And
So
what kind of notifications do you get if you go into an off-grid mode? I mean, the house, I would assume automatically shifts. You have a
Yeah.
automatic transfer.
Mhm.
Um,
Yeah, we have the automatic transfer switch, so we're shifting into the backup mode. Yeah.
right. But
so
then what does the user's experience look like? I mean, it's automatic that it happens, but then what do they see? Is it just
They
a light
actually should
change?
not notice anything. Should be, but the only thing you look at is in the app. In the
Hmm.
app, we have a energy power flow diagram and show
Sure.
you what actually giving any time we can tell you your energy consumptions, how much you use from grid, how much you use from PV, whether you charge or discharge battery, when you're in the backup mode, and we'll show you the grid is off, everything's in there from batteries and the PV. Yeah.
Yeah, those are always really neat to watch. My general user experience is like people when they first get solar, they first get the battery, they'll watch it for like a month and then they stop watching it.
yeah.
But then when there's an outage or some kind of scenario or something, it goes right back to being the most interesting thing to watch. But
Totally.
those graphs are absolutely fantastic. I've seen them.
Yeah.
Okay, so we covered a lot of ground here. Now I think that those types of outages are rare, but let me ask you, do you have like a setting? Are you able to configure the battery for a certain discharge rate so you always have a certain level of let's say power available for when the power goes out?
We don't have in terms, we can set a battery state of charge. So you can say minimum about a state of charge. We don't want to, even if your time of use, for example, you want to shift the power usage, but you also want to say, I don't want to drain my battery all the way down because in the event of power out, so you can set the minimum state of charge, say 40%.
Right.
So that is your oops moment. If the power is out, you have a backup of power. And in terms of load control, we are working with the various different partners. It's a really smart panel of
Yep.
load control. We do believe we have a very powerful cloud connect devices inside the inverter. Actually can do multiple communication points, be able to able to control some of the load. And it all depends on other things, other infrastructures you have in the house. So.
I mean, you're from a background where you're controlling lots of little devices on roof, right? So
yes.
it says to me, I wonder if you're kind of moving in that space, if it's in the roadmap to have plug level controls or circuit level controls, or even your own little load control panel. Of course, there's a handful of leaders in the market presently.
Yeah, absolutely. Yeah, because we think you don't even need, in our case, you don't even need a smart panel. For us, we just do the plug control. A smart plug should be very easy. Yeah.
It is a pretty elegant solution, the plug controls or the circuit level controls. Okay, well, here's another thought. Just when we kind of moving back to the economics a little bit and O&M and longevity, which is how we began the conversation. So when you chose lithium iron phosphate, right? And of course, lithium iron phosphate, we've talked about this, Jay, plenty, but it tends to have a better prospect for longevity at the tail end of its life cycle than some of the other chemistries out there. Did you choose it for that? What is you have safety, of course, as well. What is the prospects? Of course, you have warranty, but then you have kind of true life cycle potential. What can you tell us about the lithium iron phosphate and the specific type that you're using?
Yeah, I think it's we look at the chemistry, it's all of above you mentioned. It's performance, life cycle, and availability, the supply chain as well, right? So we look at all of this. I think this is a very good choice because our product can perform up more than 6,000 cycles, and we provided more than 11 years of a warranty, which is leading. It's a leader.
That's interesting.
Yes,
because they're always 10, so it's 11. I like that. So you got a 6,000 cycle. And what is a cycle? Just because we've
define a cycle, please.
Right. Cycle is battery goes through completely charge and discharge. Right. Let's say you go from 10%, which is the minimum state of charge, go up to 90%. They come down to from 90 to 10, that's considered as one cycle. So if you from 10 go to 80, you charge up, top up, but that doesn't consider as a cycle. No.
Oh, interesting. And there's a log, obviously, of those cycles. And you say, okay, well, you did X amount of cycles over the years, and now we're at the tail end of whatever. So, okay, interesting. 6,011 years. And then, of course, there's a potential for it to last beyond that too. I mean, so what I wanted to ask, I wonder.
It doesn't just end. I mean, you get reductions in capacity and such, but then the battery doesn't stop working.
Correct. That's what we guaranteed is the capacity in the end of the capacity, not the battery doesn't work anymore. So at that point, probably everyone want to switch different batteries anyway. So,
right. Yeah. Two quick questions. What are the voltages of a lithium iron phosphate battery bank? And well, that one first.
Sure. So maybe I should step back. So our 10 kilowatt hour, battery, comes as a cabinet. With the BMS control inside, the built-in, then we have 3 slots where you can put a 3.3 kilowatt hours.
So it's modular.
The module. So it's modular. It's lightweight for installation. And also easy in the event something goes wrong, it's easy. You can swap out one battery cells, one battery module versus the other. Its connection is very simple. It's a pure wired. All you have to do just connect them plus minus and the serial connection. So those are 10 kilowatt hour battery. And what was your question? I think I forgot.
No, that was actually where I was going to go with it. So I wanted to know the voltages. But
the voltage.
I wanted to understand how it was configured as a second question. So you kind of jumped to the
configuration. Yeah. So the voltage is a high voltage. It's got a DC-DC converter inside. Each battery module, it's 51 volts. But then the serial is 150. But then input into the inverter is high voltage. So that is we got a DC-DC converter inside it to boost the voltage. And that's what gives the high efficiency.
I see. And then what is that round trip efficiency? Let's say panel to storage, for example, before panel to inverter.
Our system rated CEC rating is about 98% system rating efficiency.
So it's right up there. It's right up there on the top of it. Very good. Okay, we covered a lot of ground. Jay, are there any looming big questions you have for Jen?
I don't think so. I want to see that automo electric EV
Yeah,
charger
we should talk next year.
for sure.
Yeah.
That's the biggest thing, the next piece of the puzzle, right?
Yes.
But we're really pleased again to have this conversation. I do want to see Tigo installs all across the state, and let us know how things go out here for you.
Yeah, no, thank you. Yeah, well, we definitely, it's Hawaii is one of the important market. I think we have our teams going to Hawaii visit and just see how we can populate that market.
Yeah, I really do think that this TOU conversation is going to give you some opportunities.
Yes,
What
yes,
I've
thank you.
what I've heard recently is from the top installers by volume, they describe the current market dynamics as better than NEM. And NEM that says a lot to people that have been in this market before, because NEM was like the Wild West. It was just put it on roof. I mean, we were running and gunning really hard in the early days of NEM solar. So the language out there is that we're going to see tremendous increase in volume back to the NEM and even beyond that in terms of volume, and people are going to be looking for technologies, and people are a little bit more mature in their understanding of photovoltaic and batteries and EVs, and they're going to say, hey, what are my options? So they're going to want to understand more specifically what the characteristics of the systems are and what the background of the company is, and then also is the company going to be there to support us through the O&M process through the years? That's a big question, by the way, on people's minds out here as the market matures. So I think we've covered a lot of ground there. Is there any final words here that you'd like to bring in, Jing?
I think I really thank you for the opportunity. I think, Hawaii is a great market. It's, we like to be there with the solar to grow the market together with all the installers there and the customer.
Fantastic. This has been Jing with Tigo Energy. We've known about this company for a long time. It's good to see them jumping into the Hawaii marketplace with this new solar plus battery offering. Some pretty unique tech. Thanks, Jason, for coming in here from Osaka. And aloha, folks. This is the Solar Coaster. We'll see you again shortly in the next couple of weeks.
Yeah. Thank you.